ordinary Kriging interpolation. Using ordinary Kriging for stationary data.
Now we are going to see the script to estimate the log 10 for the air quality index in those locations where we don't have samples. Then what is going to be is the ordinary Kriging interpolation. Then to do that one, we are going to create a new script. I'm going to paste what I did already. Then I'm going to make this screen bigger. And let's go to talk a little bit about this script. I'm going to save this script with this name. That is going to be number 1 for ordinary Kriging. Then cut, remove these two columns, these two rows over here. Then save. Going to save in this folder that appears by default. Paste. And save. Oh, what happened here? I have one already. I'm going to replace this. And I'm going to save with this name of the group. Then all this information, well, let's go to see here. Maybe it's going to be better. Then here, Kriging interpolation is this one. Then double click. All these options that appear over here is these things, right? All these things. That is going to be the layer, the field, the cutoff we want, the lag distance, the nugget, the model we are going to use, the range, the partial seal. Remember that the partial seal, the range, and the nugget are going to be values approximately, okay? Because the model is going to be fit on the data automatically, okay? I have an option to select the number of data samples that we want to use to create the model, to create the Kriging interpolation, okay? Because if we have a lot of data points, you know, we can make a smaller number in order to reduce the time of the computation, okay? Is this one that by default appear 25. Then also we can use the extension of the interpolation. Then it's going to be a couple of options: convex hull, and also layer extents. We are going to see that one later. The resolution for the pixel, that is very important. And also these two is because we are going to create two different rasters. One is going to be, these two is because we are going to create two different rasters. One is going to be associated with the prediction and the other one is going to be associated with the variance. Then the next thing is the libraries that we are going to use. That is going to be GStats and also SP. This one is for the models. This one is also for the models. And this one is for the grid. This for one type of grid. Remember that we are going to create two different types. This one and this one. And the first one is for the convex hull. And the second one is for the layer extension, okay? We can decide what we want. It's also this one, right? And then this information is to define the field, the parameter of interest. This one is related with the variogram. That one is to fit the variogram on the data, okay? That's for the model. Then this one is if we are going to use the local values to do the Kriging interpolation, or no, this one is for the local ones, and this one is if we want to use all the data. And that's it. That's to export the maps as a raster and load this information on QGIS. Now we are going to add a help file that is going to be added over here. Now we don't have any information here because we don't added anything, but with that help file it's going to be information to fill all these fields over here, okay? Remember that we learned how to create those files in the lesson 9th of the first files in the lesson 9th of the first geostatistics course. Then I created the file already. Is this one? It's just a note, you know, but it has a special extension, okay? Then double click to open. That's the information that we are going to add to the script in order to help us to fill all the information on the script to run the script properly, okay? Then I'm going to close this one here. In order to add this file to the proper folder, what we are going to do is go here. Let's go to Save As. Then we are going to see here the link. Then copy this link over here. Copy. Remember that we saved this script over here. Is this number 1. Then we can close this one, open and here, paste the link over here, then go to the folder. Where once we are in the folder, then we are going to paste that file over here. Then copy. As you can see, it has extension help. Copy, then paste. And as you can see now, number 1, we have the file over here. Remember, the both has to have the same name, okay? Then we can close this one here, we can close this one here, close this one here, and run the script again to see the help, okay? Kriging Interpolation, double click to open. And now we can read all this information to fill this one properly, okay? Then first, select the layer, is going to be this one. The field is going to be 300,000. For lag distance, is going to be 30,000. And remember that we are using the omnidirectional experimental semi-parallelogram. For the Nagel effect, the value is going to be approximately. The model, as we said, we can use any of these two. In this case, we are going to use the spherical one, as we was checking with the cross validation. For the range also is approximately. I'm going to add this value over here to 250,000. Partial seal, approximately again. Here I'm not going to use local values. If you want to use the local values, then you can select this option here and select the number of samples you want to use. In this case, I'm going to use all the data, because for a range of 250,000, that is going to be approximately the range, and we don't have too many data points, okay? Then the time of computation is not going to be very long. Then I'm not going to select this option, okay? Then for the extents, as I said, we have a couple of them. First, we are going to run this one. Then I'm going to show you the other one. For the resolution, what we are going to do is create a matrix. Then here at matrix, this script, it comes by default on QGIS. Then double click to open. The input layer is going to be this one, and the field, we can select this one, and the target is going to be this one, and the field is going to be the same, this one. Then we can run the matrix, and this matrix is going to give us the distance between the points, okay? Between all the attribute table. And what we can see here is that the minimum distance between 2 points is going to be 512 meters, and the maximum distance between 2 points is going to be 1,187,195, okay? Then we can take the minimum distance for the pixel resolution for the raster. But even as you can see, we have just 1 point with this distance. It's not very representative. Then the next one is around 1,000, and the next one is around 2,500. And I believe 2,500 is going to be good enough, okay? You don't want to put a pixel resolution smaller than this data, because you are not going to have any any information, right? Then enough, okay? You don't want to put a pixel resolution smaller than this data because you are not going to have any information, right? Then you are going to extend the computational time, but the resolution is not going to be better, right? For example, if you are adding here 100 meters for the pixel resolution in a grid that is 500 by 500, all the pixels are going to have the same resolution, the same value, because you don't have a lower resolution. Then you don't want to create extra pixels where you are going to have the same information, okay? Then in this case, I believe a value for pixel resolution that is 2,500 meters is good enough. It's not going to take a very long time, the computational, and it's good enough for this case, okay? Then, and at the moment, we are not going to save the information, but you can select also if you want to save. We are going to run like this. Also, I added here the script to give us the information related with the model, okay? Then now we can see here. That's the interpolation map. And also, if you are doing for the layer extension here, with the convex hull, what we have, let me move this one a little bit here. What we have here is the exterior perimeter of the data, okay? As you can see, we take this one out. This one is for the variance, and this one is for the prediction. You can see the convex hull, it's the exterior perimeter of the data, right? But if we are using, we don't longer need this one. If we are using the other option, the layer extension, let's go to run this one. The computational time is going to be around 10 times bigger, and the dimensions, the extensions, is going to be the maximum and the minimum value for the coordinates for the data points, okay? Where we have the maximum value here, right? And where we have the maximum value here, and also here, and also here. And that one is going to be the limits for the layer, okay? And we are not going to use this one. Then I'm going to remove this one, remove the layers, okay? And we are not going to use this one also, remove, okay, the layers, okay? And we are not going to use this one also, remove, okay? We are going to use this one, but oh, sorry, no, I want to remove this one and use the other one and cut the raster with the shape file of the shape of the state of California. Then I'm going to run this one again. I'm sorry. Then we are going to remove, we can close this one already, and we are going to remove this one. Okay, and this one, remove. Okay. And then we are going to cut these two layers, this one and this one, with the shape, with this layer, with the yellow layer. Then I'm going to place here this one at the top. Then go to raster, extraction, clip raster with layer is going to be the prediction. Mask is going to be this one. And this one doesn't matter. Let's go to run like that. Okay, it's finished, close. Then we can take this one, and this one is the layer we cut. Then let's go to rename this one, cancel. Rename, and it's going to be the Kriging prediction. Begin prediction. Then we can remove the prediction, this one. And we are going to do the same, but with the variance. We want this one. Then raster, extraction, clipper, variance, mask is this one. Then run. Then close. And we no longer need this one here. No, this one. Then we can remove this one here. Remove. Okay. And that's it. Now we can change the name of this one. Rename the Kriging variance. Now what we want to do is remove the transformation. Remember that we did the log trend transformation, and now we want to get the original values. We did a lesson on the second geostatistics course. It was the lesson number 7. And over there you have all the steps that you need to do in order to reverse the transformation. Then to do that one, what we are going to do is go to raster calculator. Then to remove the transformation, we are going to use the base 10. And that one is going to be to the power of this layer, the Kriging prediction. Then we are going to save this one in this folder. And we are going to create a new folder that is going to be rasters. And we are going to save that raster in this folder. It's going to be predictions. Save, and then we can run. The layer is already created. Predictions is this one, and now we can add the intervals. Okay, this layer goes from the minimum value 12.15 to the maximum value 159. Then if we check the data set, let me close this one here. If we go to the data set, to the attribute table, we can see here what is the maximum and the minimum value for the air quality index. We have minimum value is 10. And here the minimum value is 12.15 and the maximum value is 174, and here the maximum value is 159. Okay, as you can see, the values are not identical, but the approximation is really good. Then we can close this one here and add the symbology for this one. Then we are going to use the same symbology as we are using over here. Then go to this one, this option here, equal intervals. We want to use 4. Then here is going to be 50. Here is going to be 100 here. Here is going to be 150. And here is going to be 200. For the colors, this color is going to be green. Okay. This one is going to be yellow. This one is okay. This one is orange, is good. And this one is going to be red. This one is good. Apply. And here we can add the interval, right? Here is going to be from 0 to 50. Here is going to be from 51 to 100. Here is going to be from 0.01 to 150. And here is going to be from 151 to 200. Apply. And that one is going to be the result. Then we can the result. Then we can take the matrix because we don't want to see the matrix, and we can add this one to the top to see if the values match. And as you can see, it matches really well. Even if we are changing the range here from 50 to 200, it doesn't mean that that one is going to be the range, right? The range is the original one. But with this classification, we make the colors, right? Then if you want to see the original values, just go to Properties, Histogram, Compute Histogram, and here you're going to see what is the values, right? The minimum is 12.15 and the maximum is 159. And that's the values that we have here. We want to compare the values associated with the data set and with the values that we have in the raster. Then you can click this button here, Information. And for example, you can go for any of these points. If we have selected the vector point, then click on the point, you are going to get the data. For example, in this one, the air quality index is 119. Then if you want to know what is the pixel value, then you can click on the raster layer and now click on the pixel. This one is just at the middle of 2 pixels, but we can check both of them. This pixel, you have the value here is 114, and for this one, we have 113. But remember that the original value for the vector point, it was 119, right? Let me double check now. It is 119, okay? We don't have the exactly value because different things, right? One is because of the transformation. When we make a transformation on the data to log 10, then the values are going to be always different, right? We are never to recover the same values. That's the price we have to pay when we are doing data transformation. Also, this value is just for one point at the space, right? For a vector point. And the value that we are getting for the pixel is an average, right? Then we have for all this extension, we have the same value for the pixel. Then, for example, we can check a different value. One of these ones that are the highest. Here for the vector point, the value is 166. And for the pixel point, we have here 66. And for the pixel point, we have here 158, okay? The Kriging Interpolation has lower values. Then here, for example, for this point over here, we have 122. And for the pixel, what we have is this one, we have 113. And that's it. Then the next step is going to be the create the map. Then I'm going to save the project and I'm going to save the variance because it's now safe, as you can see over here. Then I'm going to export, save as, and I'm going to save in the folder of the rasters. Then here, rasters, save, and OK. And I'm going to save again. Also, as the symbology for the legend here, it's not pretty clear for the prediction. We can change that one for a different type of legend. Then we can go to the properties, and here we can select this one, legend settings, and then we are going to unclick this option that is showing use continuous legend, and we don't want to use this one. Then OK, apply and apply. And now we have a better range that is showing the green goes from 0 to 50, the yellow goes from 51 to 100, the orange goes from 101 to 150, and the red goes from 151 to 200. and that one it's more clear than that one. It's more clear than the other legend.